This can be the intro. Oh, he's getting the dinosaur out.
It's camouflaged against the pillow.
Yeah, that's not a good color combination there.
Sizing himself up.
Yeah. Is he happy with it? Good background?
Way.
Hello and welcome everyone back to BoneHeads. We've got a slightly different episode for you this week. We're all back home. Well, they are. I'm back at uni accommodation temporarily. And we're going to do a sort of what was originally meant to be a Christmas special, but we've kind of repurposed as a New Year's special on polar dinosaurs. And that's including the North Pole and the South Pole. And not just dinosaurs, actually. We're going to talk about Ichthyosaurs and Plesiosaurs as well, because we can't help ourselves when it comes to marine reptiles. So, yeah. Hopefully this format works. We're obviously still going to be bringing up things on screen and showing it, so hopefully that goes okay.
At least we get rid of the echo.
Yeah, no more echo problem. Hopefully the sound balancing is alright, but we'll, yeah, I'm sure it's fine. Yeah, I mean, we're going to kind of try and keep this as brief as possible because we've got a lot of notes on polar dinosaurs. We're going to try and just ignore all the news that's happened recently. There's been a lot, but that's all stuff we can talk about in January, I think. We could do like a summary of just everything that's happened over the last...
Just a summary of what we've missed.
Yeah, exactly.
Restrain yourself with the Ichthyosaurs, Ben. Restrain yourself.
Oh my god. Yeah, that new paper, I really want to talk about that in a video, but we won't do it
recently
here.
talked about the new croc from Brazil, didn't you?
Yeah, last episode of 7 Days of Science I did yesterday.
Artanachampsa
is a pretty cool name. I do like that name.
I thought that had already been taken.
I thought it was taken as well.
Sounds like something that you'd expect would have been, but apparently not. So it's a good name, good paper, and you know one of the authors, don't you?
Hey, me?
Yeah.
Do I?
Montefeltro. He's on it.
Wait, was Montefeltro?
Yeah, he's on the paper.
Oh, yeah, Philippe Montefeltro. Yeah.
Been in contact with him.
He's a very, very, very helpful paleontologist. He's helped me a lot on my project.
That's pretty cool.
Really nice guy as well. But I completely forgot he was on the paper.
Yeah, I mean it's a Brazilian croc. Of course, he's gonna be on it.
Yeah, because he works. A lot of his papers are on the Barrasukids or the bigger crocs. So the weird and wonderful world of Brazilian crocodiles. But we're not here for that.
We're not. No, let's get back on track.
They're not very
for the freezing dinosaurs, you could call them.
Yeah. So shall we start in the north, the far north, Yorkshire? No, not actually.
That's as far north as it gets. We don't.
Oh, in the Cretaceous, that wasn't that far north.
We're going further north than that. We're going to Alaska. I'd love to go there actually. So yeah.
To Alaska? Question mark.
I'll bring that up later. Now
we get lost in Alaska.
That'd be amazing. I'd love to go. But yeah. So Alaska is interesting for many reasons. In terms of paleontology, dinosaur paleontology, it's interesting because it's home to something called the Prince Creek Formation. And there's a lot of very interesting dinosaurs have been found there. So, this is an early Maastrichtian formation. Oh, I was just going to Google it and kind of bring up some images. There's some really nice paleo art. Hang on. That's the correct one to switch to. I did it. Okay.
I like paleo art.
I don't think you're able to see it, but...
Oh, damn.
That's too high tech for us. Oh no, hang on, things are happening in Discord. 1 second.
Yeah, we're lucky we got me on this.
Yeah.
Oh yeah, gosh.
Took a lot of effort to set up.
What was the formation called again?
It's the Prince Creek Formation. And
there's another formation in the middle Turonian. There's the Matanuska Formation. Apologies if I butchered the pronunciation.
I'm not as familiar with that one. I've mainly just looked up Prince Creek. Is that also Alaska?
This is Alaska, South Central Alaska.
Oh, okay. Does it also preserve dinosaurs?
Oh, this is quite a bit later.
So you've got dinosaurs. They say because it's part of the Seaway.
I
can't remember.
Okay.
Seaway it's called. It's the
Interior Western Seaway.
Yes, yeah.
It's not anything special.
Oh right, yeah.
No, it's nothing special. No, most of us didn't like it.
Yeah, no. Prince Creek Formation is something else. It's early Maastrichtian. So the Maastrichtian is the final stage of the Cretaceous period. So it's like the smallest section of time It's right right at the end of the Cretaceous, basically. That's where the majority of the dinosaurs come from, at least. I think it actually spans a little bit further than that, but the dinosaur section is early Maastrichtian. Located in Alaska. And yeah, interestingly, the conditions back in the Cretaceous would have been a lot warmer than they are there today. But there would still have been quite extreme like variations between seasons, especially in the different light levels. So they would have had, months of pure darkness, and limited resource availability. A lot of variance in temperatures. And apparently there's some work's been done. They found it could have been partially isolated from the south because of a mountain range called the Brooks Range. And that actually might have kind of led into the dinosaur diversification that happened there, and all these like different species kind of appearing in this
permanent geographical border.
Yeah,
it's
to
not
the
like
south,
a
apparently.
seasonal thing.
No, it's a mountain range, apparently.
No, I wasn't sure if ice blocked it off at certain parts of the year.
Maybe I don't know. I mean, I imagine it would have become a lot more difficult to travel through during the winter. You'd think, but I mean, probably the most famous dinosaur from Prince Creek Formation, it's got to be Nannopterygius, right?
Really? I would have said Pachyrhinosaurus.
Well, yeah, but I mean, like, unique to the formation.
In Prehistoric Planet, didn't they?
Oh, they did. Well,
yes, we have they were like the furry Pachyrhinosaurs, weren't they?
Yeah, with the goat eyes.
Yeah.
No,
this
those
is
were cool.
weird. This is a different way of opening images.
I might say some heresy right now, but I did actually quite like the Pachyrhinosaur designs in the Walking with Dinosaurs movie.
Oh, see, yeah.
See, if you watch that movie muted...
Yeah, and if you add, like, your own narration and music and stuff, it's great.
Oh, that's something we could do, a dub over.
We should. Like, honestly, that film, scientifically, like scientific accuracy-wise, it's still holds up and was, like, incredible for the time. And the CGI and everything, so good. And then just, why'd they have to ruin it with the voiceover? I don't know, but yeah, no, the designs were nice.
Was it Alex the Anchiornis was like
Alex the Anchiornis, yeah.
Yeah, I just remember his accent is in the back of my head right now.
Yeah, what a film.
But I'm looking at the list of dinosaur fauna found in the Prince Creek Formation, and there is a lot of raptors, like Dromaeosaurs.
Yeah, that's something I'm gonna come to. So that's interesting because, well, they've got a record of Troodontids there. And actually Dromaeosaurids. So I mean, I can talk about that now if you want, if we're going straight into that. There's a paper talking about how so Dromaeosaurids themselves, like the raptor dinosaurs, they're mostly just known from the teeth there. But then in 2020, there was a paper that actually described a symphyseal portion of a small dentary with 2 zyphodont teeth. And it was assigned to a Sauronitholestine Dromaeosaurid.
Yeah.
So, yeah, I mean, I don't think they could name it. Really, it's not based on particularly good material. Sorry, if I look distracted, it's because I'm also doing, like, the switching and stuff today.
Yeah,
so let me just
my screen has been split in half, so I've got camera there, so you guys here below, and then I've got the screen next to me.
I'm just switching in between. I'm not that advanced. I don't know how that...
I'm just bringing up these papers I was talking about.
It's got to be a new species technically, because obviously that's got to be very far north of their range, but
do you pronounce it as Sauronitholestes?
Sauronitholestine.
Well, that, and we have to go to this place. It was found in a place called Old Bone Beach.
Nice.
How cool does that sound?
Yeah, I don't think there must be images. But yeah, so here's the fossil they're actually talking about. So it's... Oh, you can't... This is so annoying. You guys can't see this, but I've got the image of it in the paper up on my screen, at least.
I've got the image on my screen.
Yeah, and it's...
I can imagine it.
So just like the front part of a lower jaw from a dromaeosaurid, and showing like some teeth erupting from it. And yeah, I mean, that's basically the only decent-ish record of a dromaeosaurid they've got there, for now, at least published. But clearly there were these animals there. And then also, so I believe... Yeah, okay, so this is the other interesting thing. So Troodon, famously, or I don't know, famously now, not valid, basically, because it was named based on teeth, and they decided that wasn't enough to properly like show enough distinguishing characteristics to separate it from other similar dinosaurs. So the name Troodon is now not valid,
Yeah.
but Troodontids as a group are still.
Mm.
The name Troodontid
believe-
applies to the group of
I
those
believe
sorts
they
of animals.
split a lot of those specimens up into either Lativenatrix or was it Stenonicosaurus?
Yeah, that one. I can never
Yeah.
pronounce that properly.
Although I can't remember. Is it Lativ? Yeah, I'll do a quick look.
Yeah, but
Which one is the Alaskan one?
So yeah, that's what I was gonna say. The Alaskan Troodontid, I think, at least when it was described, they just assigned it to Troodon spa, so just like a general like unknown unspecific species of Troodon. But the really interesting thing about Troodon teeth, or Troodontid teeth from the Prince Creek Formation, is the fact they're about 50% larger than the specimens known from southern Alberta and Montana. So when they're in the north here, they're a lot bigger. They say they're pretty much, like, morphologically, they're pretty much the same as this taxon when it's found in more southern areas, but they're a lot bigger. They also looked at the microwear patterns of these teeth, and they found they were again preying on the same sorts of things.
Sounds like a territorial thing.
Well, I mean, it could be something to do with Bergman's rule, which is, I mean, that was my kind of idea when I read that, is that it's the idea that generally animals further towards the poles are bigger, right?
Yeah.
It's to do with kind of like heat retention and stuff, right?
Yeah, it's basically animals towards the poles will live longer and be bigger, whereas animals towards the equator will grow quicker and be sort of more diverse and abundant, but they'll die quicker.
Yeah.
And they apply that to pretty much most vertebrates, to be honest.
Yeah.
Although you've got Nannopterygius, which is
I was going to say that kind of breaks the rule, but this Troodontid thing.
Yeah.
I'm just going to go back to
That's interesting.
formation stuff. But,
See, I've heard of that before, but I've completely forgotten what it was. But that's really interesting.
Yeah, so the Troodontids at least seem to stick to this, and in some of the papers describing it, they actually suggest that the large eyes in proportion to the body of Troodontids, when you compare them to other theropods, they like famously have quite big orbits and everything, could have given them that advantage in the low light conditions of this like extremely variable environment. So therefore they could get more prey and grow to larger sizes than other theropods in the Prince Creek Formation. And they also say perhaps it's because, this environment, the animals here are quite different to the more southern places they find them. So there's different like combinations of animals here. There's fewer Tyrannosaurids. Tyrannosaurids also aren't as big here, at least as far as we know. So yeah, it's quite interesting.
Yeah, was Nannopterygius fully grown? I know we haven't got a lot of it. It's basically just a dentary.
I may have written that. Oh, I believe it is.
Oh, okay.
Yes,
Yeah, I
it's
mean,
fully
I know
grown.
it's kind of hard to tell because
In my
the
notes,
material
I got it.
really isn't great.
So yeah, let's go to Nannopterygius. Yeah. So yeah, probably most famous. It's like it's a dwarf tyrannosaur, an actual dwarf
It's the polar
tyrannosaur,
bear,
not
as
like
we
the
call
other
it.
one. Yeah, so it's from the. I wrote this down somewhere. I'm not going to be able to pronounce this properly. Let me just get the name up.
What, the subcontinent Laramidia?
Laramidia?
No, it's
Well, that's the subcontinent I think the animal's from.
this word. Oh, you can't see it. Inupiaq word for polar bear, Nanook. A group of Alaska natives. It's their word for polar bear, and then combined with a Greek word for lizard, which is a pretty cool name for a tyrannosaur.
Oh, here you go. However, so it must have been. So someone stated that the holotype of Nannopterygius represents a younger individual.
Okay.
Based on physical evidence of undescribed teeth and postcranial remains of a larger individual, closer in the size to other North American tyrannosaurids like Albertosaurus, Sarcophagus, which is 8 to 9 meters in length.
But it's undescribed, so
Yeah.
let's give it that grain of salt.
Yeah, like you said earlier, they say that the Nannopterygius is a dwarf tyrannosaurid.
Yeah.
Oh, they
And
still do say that.
Are
then.
those actually from the Prince Creek? Because if they're not, then you can't confidently.
Yeah.
Especially since if you've not got the same material, then how can you
It doesn't say
confidently?
here. It just says
that's
it just
true.
mentions that there is a bigger individual.
That's interesting. It'd be cool to see more work done on this.
It could have maybe got bigger.
Yeah, because Nannopterygius itself was only named in 2014, based on stuff that was collected in 2006.
You'd be surprised. Something like this would get a lot more coverage. Like, people want to know what Nannopterygius looked like, what it was.
It's really interesting.
I remember there being loads about it.
I'm surprised they haven't done even more expeditions trying to find. Probably they have, and it's just taking too long to prepare.
Maybe. I know, like, it's going to be difficult fossil collecting conditions in places like this.
The first occurrence of a sort of, colder climate tyrannosaur, because you got Tyrannus, which is hypothesized to live in
That's true.
a colder climate as well. Based on the paleoenvironmental analysis and the fact that it had that huge covering of feathers.
Yeah. I mean, in a lot of paleo art, you see Nannopterygius with feathery integument like all over the body, which I think you can pretty safely say if Tyrannus has that, probably did as well. But then,
especially since in colder climates, it's those larger animals that do survive, not just because of Bergman's rule, but because they have that smaller surface area to volume ratio, so they're losing heat at a slower rate.
Exactly. But then, I mean, that could that potentially have interesting implications for T-Rex itself, because it's Nannopterygius is quite a derived tyrannosaurine, right? So when they first described it, I've got written down, it was just outside the more derived than Plesiosaurus, than just outside the Tyrannosaurus plus Tarbosaurus plus Zoocheng clade.
Did you check the new phylogeny based on?
Yeah, so the one where they described Thanatothyristes, it's less derived than Plesiosaurus, but it's just outside.
They put it outside.
Yeah,
they put it outside Plesiosaurine.
But it's still pretty derived Tyrannosaurine. Oh yeah, so that's quite interesting.
They're not going directly all towards that trend of larger body size.
Yeah.
If Ankylosaurus is a dwarf species.
Yeah. But I mean, they don't have much material of it. The holotype is some disarticulated parts of a skull. They've got the maxilla. No, that's not. I mean, it would be here. They're not actually showing. Does it show what we've got? Oh, here we go. There's a bit of diagram showing.
Material.
A bit of the maxilla, bit of the dentary. Oh, and there's a partially erupted tooth. Oh, you can see it there. This partially erupted tooth in the dentary, which is quite cool.
I guess if that undescribed material does have teeth, then you could maybe.
Yeah.
Still hard to say.
Oh, and they've also CT scanned the dentary apparently, and they found like quite a few unerupted teeth within it. So that's pretty nice.
I was just reading up where it was found. What was was anything going on with the discovery when they found it? But nothing much. It was found back in 2006.
Yeah, I didn't actually realize how recently named, like in 2014. Because I don't know. I guess I wasn't following paleontology news as closely as I am.
I remember it being announced. It was sick.
Yeah, no, I'd have been hyped for that.
Yeah.
I mean, I am. It's a cool dinosaur. So the skull is apparently estimated at just 60 to 70 centimeters long in fully grown
60
animals.
to 70 meters long.
Yeah, no, that would be quite interesting.
Fairly small for a fairly derived tyrannosaur. Like the Plesiosaurs we were looking at the other week, they were around a meter long, those skulls, just over. So it's a fair amount smaller.
Yeah, definitely.
If it's a fully, mature individual. Probably we just don't know that too much about this animal.
Yeah. I mean, they say it is... Well, they say it's mature, but I don't know. We need more material. It would always be nice. And in the paper describing it...
If they ain't cut it open, I ain't buying it.
They CT scanned it.
Do you think they're going to cut open the only specimen? If someone came to me and proposed that, I'd tell you get out.
But no, I think Prehistoric Planet did a good...
Oh yeah, let me bring up.
I was going to bring something up. Was Nannopterygius the one that was blue, or was that the one in China chasing the ornithomimosaurs?
Oh no, that was Qianzhaosaurus.
Antarctic. Okay.
It's
So
the
Nannopterygius was the orange one.
Yeah, yeah.
With so
Kinda
what? That's
orangey.
an interesting color choice.
It's just
There you go.
The
It's
thing
nice.
is, one thing I want to also bring up was that in Prehistoric Planet, they made the setting quite with snow and quite cold, but we know that it wasn't that.
I mean, not always. I think it was showing the seasons,
that was
wasn't it?
during the winter time.
Oh, so just showing different seasonal
yeah.
changes.
Yeah.
Well done, Naranesh.
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 Oh.
Who do you think I said?
No,
Yeah, they cut out.
it's definitely sort of a recent thing, or exploring the temperate zones in the Mesozoic, because obviously, like, it's generally thought of, well, it was, the last 50 years or whatever, that it was very hot, humid, swampy, and I feel like that's changed a lot in the last 20 years, especially with things going on in Australia, and really changed our idea of how dynamic Earth's climate has been.
Well, we'll get to Australia soon.
Oh yeah, I've got some things to say about Australia.
Saying how.
Yeah, so another of the really interesting dinosaurs they find here. Sorry, I'm switching around again. Is of course Pachyrhinosaurus.
I'll have it up on my screen, and it's probably one of my favorite. One of my favorite ceratopsians. Bloody hell!
But that also features in Prehistoric Planet. Let me just find that. The interesting thing is they've got like an entirely new species from Alaska specifically.
Which one's that?
So it is called Pachyrhinosaurus peritorum.
Quite a fairly recent discovery.
Yeah, so it was named in 2012. Sorry, I'm gonna do some switching again. Here we go. This is the
so a lot of
this
Prince Creek work is done in the last decade, really. Then.
Yeah.
One thing I absolutely love is that there's so many differences in these Pachyrhinosaur skulls. Like, you've got the ones that are like jagged edged horns, you've got the smooth ones, you might have a bit of a horn protruding out. They're amazing. They remind me a little bit like the Ankylosaurs, where they're changing their clubs to fight one another.
Yeah,
it's interesting.
I'll bring up. I think there's diagrams of all three.
Oh yeah. This is Philip J. Curry's like area, isn't it?
No, that's not it.
Like this is one of his dinosaurs he loves to like work on, or they find a lot.
Bro, when you told me last week that this was the youngest Centrosaurian ever known, I was so sure. I had no clue. I didn't realize they just they just went out by the end of the early Maastrichtian.
Yeah, so I was going to say that's why this is quite a quite an interesting specimen, like for the ceratopsian evolution as a whole, because it is the youngest example of, so not only the youngest of the three Pachyrhinosaurus species, but it's the youngest Centrosaurian that we know of so far. So the ceratopsians split into the two main groups, like in more advanced derived groups. There's the Chasmosaurians and the Centrosaurians, and this is the youngest one. So like Triceratops and everything, which is around right at the end of the Cretaceous, are Chasmosaurians. This Alaskan one is the youngest known Centrosaurian, and it's also apparently close to the highest latitude for ceratopsid fossils that have ever been found so far. And the holotype, which you can't see, which is so annoying, but the holotype is beautiful.
I've got an image of the holotype.
Yeah, so it's like the whole like front part of the skull and a little bit of the top of the frill, apparently.
I was looking at the image and I was like, what is this?
Yeah.
It just looks like rocks. And then I was like, oh wait, no, I can see the eye, I can see the nasal, I can see the basis of the conda. I was like, oh, have you seen the artwork for peritorum?
I've seen. It is here it is.
Beautiful.
It's 3 species. Should just use this.
Are you showing the restoration one?
Hang on. The peritorum. Which one is it?
It's the one with the two Pachyrhinosaurs, like one they're looking at something.
Oh yeah.
Yeah, have you noticed that the one in front? Sorry, Eddie, I know you can't see, but the one in front, if you look at its frill, it's actually got some like bite marks, like with
Oh, that's so
flesh
cool.
coming down.
Yeah, around there. That's nice. So
That's pretty cool.
actually, one of the defining features of this, which I think you can see. Yeah, I think that's actually portrayed here. Apparently, one of the main differences, one of the very noticeable differences between this species and other Pachyrhinosaurus species, is like these projecting bits of the frill that go into the gaps in the frill, the fenestrae. I think that's what this is showing. Yeah, it is. So these bits, you can't see again, but yeah, people watching can see. There's like these bits that project down into the holes here, which you can't see in that pediment, and obviously the other two species don't have that, so it's just an interesting little feature, a way to tell them apart if you see reconstructions.
Do you know what's quite funny? I'm looking at this reconstruction. For some reason, with their beak at the front, and they've got this weird protrusion of bone coming down off their beak. It reminds you so much of a Plesiosaur's face.
Oh, this kind of tusk.
Yeah, the little tusk feature.
Is it almost like a shearing surface?
Yeah, it looks like it.
I don't think that's.
Oh, no, not really, because it looks.
I need to pull up a picture now.
Yeah, sorry, we should
look up restoration of.
I think it's on the
Wikipedia
by page as well.
James Havens. But the face. I looked at it. I was like, oh my god, it looks like a Plesiosaur.
Yeah, no, that is actually preserved in the fossil, and you can see it's kind of more pronounced than the other species. That's interesting.
Oh, I see what you mean now.
Yeah, right. Yes. It's almost like a Plesiosaurus tusk.
I was just looked at it, I was like, damn, I'm looking at the wrong thing. I must be.
So I'm gonna find them. So the
cool. Oh, that's cool.
Like planet reconstructions.
Have you seen the stages of skull difference between growth?
Yeah, so that was the other thing I was going to talk about.
That's so cool.
The other paper they've got on this species is a juvenile specimen described in 2013, and they basically like could kind of work out the growth stages of this animal. So it's only like a fragment at the top, like along the top of the skull. But this is from a younger Pachyrhinosaurus peritorum. I think there's a nice. Oh, that's such a nice fossil. No, that's the holotype, isn't it? Yeah. Yeah. So they kind of do like a hypothetical growth stage of how all the different bits of the bosses form over time. So that's really cool. They've been able to do that.
Yeah.
Yeah.
No, it's always good to see a bit of a ceratopsian ontogeny. It's quite easy to do considering how many specimens there are.
Yeah, it is. There's, crazy good record in comparison to other.
You think that Hadrosaur and Iguanodontian ontogeny will be easy? Depends, considering how many damn specimens we have.
And I mean, yeah, it's important considering what this animal represents.
Yeah, like the very last known. I feel like, I mean,
they could
find more.
I don't know.
Possible.
Quite a common dinosaur in Canada and Alaska and Canada, isn't it? It's one of the most common.
I think it's fairly common, yeah.
Yeah, because you get the Edmontosaurs, the Hadrosaurs, they're the most common. And then you get these amazing frilled animals.
Okay, so I'm just talking of Hadrosaurs, just finding the information on the
stole my lines.
Next one. Yeah. Okay, sorry, the multitasking of the switching and everything is quite challenging. There's so many things open. But basically, this species, Ugrunaluk.
Oh gosh, what is it? What's its name?
Yeah, I thought when you wrote that was completely a different language.
Yeah,
Ugrunaluk.
I don't actually know what the name is based on.
Oh my gosh, look at that hand.
But this thing doesn't exist anymore, sadly. It was.
Oh, what?
So it's named and described in 2016 based on more material from the Prince Creek Formation, and you might be thinking, doesn't that kind of look like just a Edmontosaurus? Well, yes. In 2017, other researchers came along and were like, that's Edmontosaurus. So they assigned it to Edmontosaurus spa, so it's just like an unknown species of it. So I think that was in this paper, yeah. Here's the one was actually described. Yes, there's this one. There's some of the that's a
Is
that's a
it a
whole reconstruction.
distinct species though?
Well, basically I think the most recent stuff, the most recent publication on it, at least as far as I know, in my quite brief research on it, was a 2020 paper, which I'll bring up now. Yeah, this 2020 paper where they say they look again at all of the material, the cranial material for the Alaskan Hadrosaurine, they call it, and they assign it to Edmontosaurus. But they're not sure what. Yeah, it's Edmontosaurus spur again, so a species of Edmontosaurus. But they say because it's actually not a fully grown individual that you can't confidently say what it actually is. But it's likely Edmontosaurus is also present in Prince Creek, which is interesting. But it's not Ugrunaluk, or however it was pronounced.
We could bring it back though.
You could, more fossils again. That's what needs to be done.
So get on the field, people.
Yeah.
Go
to Alaska.
What is that species name?
Oh, I didn't even attempt that. For the Ugrunaluk.
I think the species name is easier.
Pichiensis.
I don't know. Yeah, I'm not going to try and say that.
No.
Oh, well, hang on. I might actually remember one. Why does this look familiar?
I think, yeah, I do remember this coming out, I think.
Was this the one that had that red frill bit?
Oh, no, you think of the, when they found, like, the soft tissue crest for Edmontosaurus.
Yes, I'm thinking that. So,
that was amazing.
Edmontosaurus regalis.
Yeah, that was it. But, yeah, for now it's just Edmontosaurus spur. And so, who knows what will happen with that? Could be quite interesting.
Now, Mr. Thomas, are you recording?
I am recording. We're back.
Now, Mr. Thomas, it is time to take it away with the Ichthyosaurs.
Okay, so actually, you might be surprised to learn that there's quite a few Ichthyosaurs known from the Arctic. So keeping with the trend of being in the north, we're going to look at a few Arctic Ichthyosaurs. So there's this taxon called, and I'm just going to find some images of it, just bring up, because there's so much to say about it. It is called, one second, let me switch, Arthropterygius. So here it is. There's some pretty nice reconstructions of this. I really like this one. I believe this is meant to be Arthropterygius. Yeah, okay, it is. Cool. It's so complicated. At the moment, there's like 4 different valid species recognized. 3 of them were found both in the Arctic and European Russia. And it's thought that it might actually have been like just a really kind of common ichthyosaur genus like at this time, because yeah, it seems to be quite widespread in like the northern seas, so they call it the boreal realm, during the late Jurassic and going into the early Cretaceous as well. There's quite a bit of slightly controversial taxonomic battles with this genus.
When is there never?
Yeah, exactly. I've tried to write on the history of what happened, but basically there were 3 other genera of ichthyosaurs named. One called Palvenia and another called Cryopterygius, which I actually really like that name.
That's nice.
They were both named in the same publication in 2012. And then there was this other genus, also from the same formation, which is actually in Svalbard. Pretty cool. And that was called Janusaurus. And then they named another one. So, there's 4 of them. Yeah, named another one from the same place, same formation as Svalbard, called Keelhauia, which I don't know if I'm saying that correctly. But then Palvenia, Janusaurus, and Keelhauia were synonymized all together in Arthropterygius back in 2019, with this paper that kind of says, yeah, they were really widespread across across the planet in the oceans at this time. Janusaurus and Palvenia actually got their own species within the genus, but then Keelhauia was just said to be Arthropterygius spur, so just some unknown species. Yeah. And it possibly might be a juvenile of one of the other Arthropterygius species. That's pretty interesting. So this formation in Svalbard that they were coming from, I'm not going to try to say it. It is. It should be in here somewhere.
Is it the same one as Funke?
I believe it might be. Hang on.
Let me quickly check.
Let me switch again. This is not the best way.
Otherwise known as Prehistoric.
Switching. I got Figelet.
I'll let you know when I find it.
That's the name of the formation. I really wish we had someone switching for me. This formation. I got.
Yeah, no, it's from the same formation.
Yeah, I thought it was.
Yeah, because yeah, that'd be a very interesting biota event of that time. Then.
Yeah,
I'd love huge plesiosaurs and ichthyosaurs.
That's true. Yeah, I would love to go and do field work here. But, yeah, so it apparently it was probably just below the Arctic Circle. Apparently, there's estimates that when it was being deposited, it was about 63 to 66 degrees north, and the Arctic Circle is about 66 degrees north. So like just on the border of it, probably just below. But apparently, it was quite a cool climate because it's still very high latitude, obviously. So there could have been some sea ice around, according to some research.
Yeah, maybe seasonal.
Yeah, exactly. It would be very seasonal as well. But yeah, there's quite a few. Well, there were quite a few ichthyosaurs named from here, and now they're all thought to be.
How big were these ichthyosaurs, Ben?
I think some of them could get quite sizable. Let's see. Oh, here's a good comparison. Yeah, like 5 meters long, Arthropterygius.
Okay.
Yeah.
So fairly medium, really.
Yeah, I mean, in comparison to some of the really, really big ichthyosaurs, definitely. People always kind of underestimate
how big 5 meters is.
Yeah, like how big ichthyosaurs could actually get.
Do you know if there's fibrolamellar bone known in ichthyosaurs?
I'm pretty sure there is. I'm pretty sure yeah.
I saw your notes on the growth, like the growth rates, and I was wondering, yeah, just sort of how that compares, because I know it's known in plesiosaurs, which anything with fibrolamellar bone indicates
endothermic,
a higher metabolism and a higher growth rate.
Yeah, I'm pretty sure that has been detected in them.
Yeah, which probably is why they were able to survive at these high latitudes and colder conditions, because they could just generate their own body heat.
Yeah, seems to be most accepted now that like it is actually ichthyosaurs were endothermic and had blubber as well. There's evidence for that, which is pretty cool. Actually, like insulated, kind of like modern cetaceans.
What specimen is that in?
It's a Nannopterygius, I think, from Germany. We can do a whole episode on this, but yeah, there's some soft tissue preservation where they think there's like a kind of blubber tissue preserved in there. It's really cool.
That's very interesting.
Yeah.
Yeah, you said that what's it called, the skull elements grow slower than the rest of the body, but
the
appendicular is much faster.
Yeah, because
which I guess kind of makes sense when you sort of see, like when you see these juvenile ichthyosaurs and like the ones where they're like, fetal, their heads are much bigger than the rest of their bodies.
Yeah, exactly, and that's sort of just like a common thing with like juvenile things of tetrapods.
Yeah, larger eyes and all that.
Like so the skull elements were found to grow a bit slower, and it's thanks to like the lots of different specimens that they're all like assigning to this genus that they can actually do kind of like an ontogenetic study and look at how they grow. But yeah, the really interesting thing about Arthropterygius is that it's actually apparently present in Argentina as well. So not only is it not only is it in like almost pretty much Arctic waters, but also getting down close to the Antarctic as well. So they think it had a pretty global distribution.
Yeah.
Which is really cool.
Yeah, I guess if it's sort of like, off South Argentina, then that is sort of coming into the same conditions it is up north, just in the south.
It's quite surprising. When I was reading that, I was like, oh, what? It's just everywhere.
I'm guessing it's a different species, though, in Argentina.
I think so. I don't know what I've done with my notes now. But, so I was going to also talk about Cryopterygius, which was another one named from that same formation. Right? Yeah, I think it was. Yeah, it was. so it's late Jurassic age, and now Arthropterygius apparently doesn't exist. Let me find. It's actually this other genus.
When were
called
these ichthyosaurs described?
Undorosaurus.
Sorry.
This Arthropterygius was named as 2 different species in 2012 and 2016, and then they were synonymized with Undorosaurus in 2019. I can't see it, but this might be some of my favorite.
I'm guessing it's all one paper that just eradicated them all.
I think it was a series of them. It's kind of so it's this Russian paleontologist. Yeah, it's this Russian paleontologist who's kind of been doing like a survey of all these different late Jurassic.
The one who helped with Thalassodraco.
Yeah, or Grandelius and all that. Nannopterygius as well, which I'm guessing too. But yeah, he kind of just like lumped a lot of these species into the same genera. Yeah, Undorosaurus is really cool. So yeah, they're now all grouped together. You can't see this paleo art, but I absolutely love it. I think this is by Alora Titan on DeviantArt. Oh, here it is. This is some paleo art done by this Russian paleontologist, Nikolai Zverkov, which I don't know if that's how you pronounce his name, but this is the person who's like synonymizing all of these. And it's apparently quite a similar genus to Grandelius, which is the genus that I'm likely working on if it turns out that my specimen is Grandelius, which it seems like it probably is. So it's got this very thick, robust rostrum, quite a small orbit for an ichthyosaur, and like an expanded bit like just behind the head, so probably, you know, helping in anchoring lots of powerful jaw muscles. Lots of very robust teeth as well in the upper jaw. And yeah, there's some interesting ideas about how the fact that Undorosaurus is found in European Russia and in Svalbard, that there's kind of like this interchange of ichthyosaurs moving between these different these different seas in the late Jurassic. That's pretty neat. Then yeah, moving on to Nannopterygius, which is another interesting ichthyosaur taxon I talked about a little bit in the NHM. It was fun.
Oh, how funny is that? As soon as you said Nannopterygius, I found a paper by Meg.
Oh yeah, yeah, because she was involved with
the reprisal of the inaccessible holotype.
Yeah, so that's
taxonomic tangles and reveals an obscure ...
This is not the best photo, but this is the inaccessible holotype. We talked about it in our Natural History Museum trip. It's like mounted really high up on the wall in the Marine Reptiles Hall, and it's made it very difficult to study the holotype of Nannopterygius. But yeah, in recent years, they've actually named quite a few other species of Nannopterygius in addition to the original one from Britain. And so one of them is Nannopterygius borealis, which, yeah, so that was, I think it was named 2020?
Yeah.
Yeah. So they found 4 different species of this ichthyosaur Nannopterygius, the type species, and they named 2 new species based on things that have been called other things in the past. And then they named Nannopterygius borealis as like an entirely new species based on newly reported material. And then, okay, so as I was researching this, like it went down a bit of a rabbit hole. Turns out there's actually 2 other species of Nannopterygius that were named this year, or last year, 2022, from Kazakhstan, but the paper is only in Russian, and I don't know, like I can't read Russian, so yeah, I don't know what's going on there.
I can Google Translate and see what comes out.
I can try. My brother's actually studying Russian, so I was asking if he could translate it a bit, but
to be fair, it's worked pretty well with some of the French papers I've had to use.
Yeah, I could try that.
Just get the points across.
But yeah, this is where I wanted to kind of talk about my own ideas for Nannopterygius borealis, because when they originally named it, it came out just in what they call the polytomy, so it's like all in this big cluster, like all the Nannopterygius species. Like the exact relationships between them can't really be sorted out properly. Then in this other paper naming a new ichthyosaur from Dorset called Thalassodraco, which you may have heard us talk about, from the formation that I'm studying for my dissertation, the the phylogeny in that paper like has Thalassodraco between the 3 other Nannopterygius species that were named at that time, and then Nannopterygius borealis is by itself as like a more basal taxon. So what's going on there?
Indeed.
Then, I don't know, Eddie, if you remember when we were doing my preliminary phylogenetic analysis of my specimen, when we ran that, it came out again with Nannopterygius borealis not being grouped with the other ones.
Yeah, although isn't your phylogeny based on Meg's work, so
yeah,
that's going to happen anyway.
It's going to be like the similar results, but then adding in my specimen doesn't change it too much. So I don't know. I think there could be a case for naming the borealis species
maybe
as its own genus, which is just interesting. I mean, yeah, just putting that idea out there. I'm sure people have suggested it. Maybe it's going to happen.
Bring back Cryopterygius. There we go.
Yeah, just name it as that.
Yeah, it wouldn't surprise me, to be fair.
Yeah.
Really nice name, actually, Cryopterygius.
I do like it, but is it as nice as the final Ichthyosaur I'm going to talk about, I promise? Auroroborealia. Which also has some gorgeous paleo art. So I remember when this came out, because it was only last year.
Is it green coloured?
It's not. Who's this paleo art actually by? It doesn't even say. Shame. Okay, for some reason it's not saying. I really like this.
You find it.
Yeah. But yeah, so named 2021. In the same paper they named this, they actually also reported some indeterminate Shastasaurid remains. So these from
wait, how old is this formation?
Late Jurassic, early Cretaceous.
Huh.
No, hang on, wait. I'm sorry, it's been a while since I looked at these. I think Auroroborealia.
A Shastasaurid.
Never mind. Yeah, Auroroborealia is
Jurassic.
Different. Sorry,
it says in the paper it's Upper Triassic.
I was getting them mixed up. This is a different formation. It's still it's Russian Arctic, not Svalbard. This one is from a different formation, as Upper Triassic, and they report some Shastasaurid remains here. So the really really giant ichthyosaurs that the paper recently was about this. I'm not going to talk about it. Never mind. But yeah,
we're not going to talk about it now.
We can talk about it another time. I want to give it. I
was gonna bring up the well, I don't know anything about it. I was going to bring up the tooth found in Norway. Was it Norway?
Switzerland.
Switzerland, yeah.
Yeah,
the giant.
That's probably a Shastasaurid of some kind.
But now we've got teeth of Shonisaurus, we can compare them.
Yeah.
Oh, I actually found out something interesting when I was doing some research. So we've been reading into Dromaeosaurs a bit. Well, it turns out some of the most derived members, like their end members, are all from fairly high latitudes. Like you got Boreal and Nectes, and some of the others are from quite high latitude. So maybe this is around the Calovian in the Jurassic, I believe. So it could be that maybe during their sort of decline they were restricted to those higher latitudes. But
interesting.
Yes, yeah.
Yeah, because I think most of them are only known from sort of up there in the north. Although then again, you have got Plesiosaurus funke, so I doubt it's a separation where the plesiosaurs couldn't go further up north. So I'm not sure.
All we can say now is that the plesiosaurs are some of the weirdest marine reptiles. I'm working on a project recently, and oh my gosh, is it confusing? Well, the thing is, anyway, just marine organisms are confusing. They're so bizarre. Especially the Dromaeosaurs, because they're classed as plesiosaurs.
No, they're not.
Dromaeosaurs are Plesiosauridae.
They're
no, they're not.
Their own thing, aren't they?
Yeah, so they used to be within Plesiosauridia, but now they fall just outside.
Dromaeosauroidea.
Yeah.
Plesiosaur evolution. We could have a whole episode on that. It's so confusing.
Yeah, it's a fairly recent change over the last decade or so.
Yeah.
But they fall just outside.
Yeah, their phylogeny is not nice.
Yeah, did you want to go on? You're going to talk about some plesiosaurs. I was just very quickly going to wrap up on.
I got one really cool one from the south. So if we were ready to move on to the south,
I'll quickly wrap this up.
He
Basically,
needs to talk about his Ichthyosaurs.
Auroroborealia incognita is the second, the species name. It's actually
That's
quite
a nice name.
Yeah, I really like the name. It's quite interesting because one of the things that makes this unique, like figures of it. It's got some very unusual how the ribs attached to the backbones. Basically, is very different compared to other ichthyosaurs. There's actually only one articulation point on the centrum in the anteriormost, so forwardmost neck vertebrae. Only one articulation point on the actual centrum, like the circular bit here. And then the other one was actually on the base of the neural arch, so like the spine going off, which famously in ichthyosaurs, most other ichthyosaurs, they have both of these rib articulation points on the centra themselves. So kind of strange that is happening there.
That is
apparently,
a very big morphological change.
Yeah, apparently it's been reported in one other species of a quite not a close relative of it, but another ichthyosaur.
Do you know what it's for, though?
I don't know. I mean, it's just different, I guess. It could be like a sort of this convergence that's happening, or just like a kind of holdover from these other more basal ichthyosaurs where that's the condition, but pretty interesting. Yeah, that's what I wanted to say about the ichthyosaurs. There's much more that could be said, but it all gets very technical, and I don't know how interesting it is to kind of follow. But it's interesting and relevant to like what I'm studying, so I've been interested in reading about all that. Yeah, do you want to talk about the plesiosaurs?
Yeah,
is this the new plesiosaur?
No, this one's not new. Although it is from Australia as well. To be fair, there's loads of Australian plesiosaurs, especially from this formation.
You mentioned that. Do you know what I've just tried to look up? I can't find a list of any crocodilians from Australia.
Alligator.
There's no alligators in
I don't know
Australia.
So is it Immunosaurus you're talking about?
Yeah, Immunosaurus.
Yeah.
So I think this was the papers from 2003, I believe.
Oh, I'm such an idiot.
But this is actually such an interesting plesiosaur, because while there's loads of them, these like high latitude cold water plesiosaurs, this one has just got like a little bit extra going on about it, because it was actually found in the opal mines in Australia.
It's this one.
Oh, you're looking at a picture of it?
No, yeah. Now you mentioned the opal mines, because this is the one they also found that hadrosaur or the iguanodontian.
Don't know. But it's from a bulldog shale, which is like where most of the these really good specimens are from. Like a lot of these other dinosaurs we're going to talk about, they're also from the bulldog shale. And this is like lower Aptian to Albion in age. Although Aptian and Albion is a bit weird, so let's not get into that. But they discovered 3 skeletons. So 1 juvenile, which is like less than a meter long, and then 2 adults up to 2.5 meters. So this is actually a really small plesiosaur.
Wow. Yeah.
Yeah, it's tiny. But one of them they named Eric, and it's actually the most most complete opalized skeleton ever, like including the skull.
The right one. Is it the one that's going to come up first?
If you look up Eric, the Immunosaurus should come up. I think one of the museums has got a page on him.
I think it's the one I'm showing. Yeah.
Yeah. So I mean, not only does he look really pretty, he's actually really complete as well. Because he's got 3D preservation with actually little distortion, and there's even like preserved gut contents of teleosts, which are like these group of fishes, sorry, and gastroliths. So that's another thing we saw in a prehistoric planet.
Mm-hmm.
Oh, yeah.
But I think the thing that it just looks really cool about this plesiosaur, is really interesting, is it's got these like thin. Oh, sorry, I'm moving my camera. I'm knocking the wire. It's got these thin arching crests on like the midline of a snout. So along here, there's like 3 of them. And and above the orbits. And then the pineal opening, actually has like a high fluted crest-like margin, which is not really odd, to be fair, for a hole. But yeah, these crest structures are just like really unique, and you just don't see them in much else. I mean, midline ridges have been reported in other leptocleidids, I believe, which is the group it belongs to now. And obviously, yeah, they're too fragile for skull reinforcement, defense, or combat. So it's most likely some sort of display structure. But
Okay.
in the paper, they also say it was definitely keratinized. So it definitely would have some kind of sheath that would have made them a lot bigger.
Yeah, so I see that in some of the paleo art.
Yeah. So imagine it could be like this huge crest that just like cuts through the water.
That's nice.
I mean, I doubt it's got any sort of hydrological like advantage.
Yeah.
It'll literally just be like species recognition or display, but it would have looked
be a
very
scare
cool.
tactic as well.
That's crazy, don't you?
Yeah, well, considering how small of a plesiosaur it is, it might have helped make it look bigger as well.
It's such a weird thing to.
Yeah, no, it's extremely unique, and it makes you think maybe how many other specimens are we missing this in?
That'd be so cool.
And considering it's it's quite an odd one living in these cold waters, that could just be like a thing this developed.
So, what age did you say this plesiosaur was?
Sorry, what?
What age did you say this plesiosaur was?
Early Cretaceous.
Aptian to Albion.
Oh wow.
Yeah, so it's early Cretaceous. Oh, but the original paper, right? So they originally put it in Dromaeosaurs, which, to be frank, is quite ridiculous. To think that Dromaeosaurs lasted that long, no, because originally they also put leptocleidids within Dromaeosaurs, but that's completely changed now. Leptocleidids are now part of plesiosaurs, not Dromaeosaurs. Much better.
Oh God, not plesiosaur.
Makes much more sense.
Evolution.
I mean, they kind of like convergently similar, but overall, like, nah. It's like saying Baryonyx is a Rausuchian.
Oh please don't. Let's not start.
But yeah, it's also got like a small and triangular skull, like Leptocleidus. That's kind of interesting, just because the other Leptocleidids have slightly different shaped skulls. It's only Leptocleidus and Immunosaurus that have that triangular shape. Yeah, and I mean, I know we're going to probably go onto this a bit more with all these other dinosaurs from a bulldog shell, but there's evidence for, like, I think ice rafting and other near freezing conditions, which is how they sort of, displayed this in Walk with Dinosaurs and other stuff. And I mentioned this earlier, but plesiosaurs have been found with fibrolamellar bone, which is what sort of allows them to have that endothermy to survive those sort of conditions, which is why there's so many of them in these sort of high latitudes.
Yeah, that's very interesting, and I guess that's kind of been realized with the ichthyosaurs now as well. Is that I mean, there's like a lot of convergence with kind of modern marine mammals, which is pretty cool in certain ways. Did you want to kind of go on to the dinosaurs? I'm just
Well, I'm going to quickly butt in and say something. Okay. I'm a bit of an idiot because I just said that I couldn't find any crocs from Australia until I realized that recently we just had one of the most amazing crocodile discoveries, Confractosuchus.
Oh, yeah.
Am I allowed to talk about Confractosuchus or no crocodiles?
Well,
I mean,
is
it's
it
a bit off topic.
Icy one?
It's from Australia.
Yeah,
that's not really.
Australia's not currently icy.
It's snowing somewhere.
Trying to spell the most awkward dinosaur name ever, and I can never get it. And
what, Lianosaura?
Lianosaura, yeah. I can never get it right.
I knew exactly where I was.
We've still got a lot to get through. Should we just go on to these dinosaurs?
Yeah.
Okay.
I want to do Kralophosaurus.
Okay, yeah. We've got a lot to say about that, but I should not be the one doing switching as well. So
well, speaking of baryonyxes, as he just said earlier,
that is not a good segue.
Kinda. There has been reports back a few years ago stating that there could be a baryonycine in Australia. Was it cervical or was it caudal?
I have no hopes for that. They reported back in 2013 that they found a possible Tyrannosaurid, and that was 2013.
Oh no.
Well, there's a vertebra, and they matched it with baryonyx, and they look almost identical. But baryonyx, this group Spinosauridae, is so big it could just be anything.
You know what they definitely have there is Leanosaura. Well, yeah, at least they have the holotype.
Hold on. What does that mean?
Well, because some specimens are attributed to it that possibly aren't actually Leanosaura, which I get into. But I mean,
okay.
yeah, everyone probably.
Do you know what they
knows
also
this.
have there, and that's nowhere else in the world? Cryolothosaurus.
That is not an Australian dinosaur, my dude.
Yeah, we're getting close.
No. But yeah, everyone probably remembers the Leanosaura from Walking Dinosaurs. The adorable little ornithopod. It's found from Dinosaur Cove, which I can't believe that's a real place in Australia. I really want to go there because I know the book series Dinosaur Cove. I love those. There's an actual place called Dinosaur Cove in Australia. And it's this formation called the Umarata Formation. Yeah, it's so. I'll find the picture of the holotype.
Oh, I thought some of these were from the bulldog shell, but I'm guessing probably not then.
Not the ones I've got here.
Oh, it still shows there's a lot of ice going on.
Yeah, so there's a bit of the skull known for the holotype. I'm pretty sure this is also the holotype. It's attributed, but I swear that is.
I just had the dinosaur. Where to go?
A bit of a skull roof. And then yeah, so one of the really interesting things about the Leanosaurus is the idea that it had this like ridiculously long tail. But that's actually based on a specimen that may or may not be Leanosaurus. That's been debated recently. But yeah, if it did belong to Leanosaurus, then it means it had over 70 vertebrae in the tail and no tendons, no ossified tendons to strengthen it. So it's like super flexible if this is Leanosaurus. I mean, obviously this tail exists, whether it's Leanosaurus or another kind of ornithopod.
I was going to say like Tenontosaurus, but that's got ossified tendons if I remember correctly.
Yes, it does, yeah.
But so
it's not like that then.
No, they just think it could be really, really flexible. And then I love the idea that people have suggested that means if possibly Leanosaurus did have feathery integument as well, could it have a really fluffy tail that it then like used to wrap around itself in the cold, and that's why it has no ossified tendons and it's really flexible and really long to like literally wrap around itself.
It's really sweet.
Help it sleep. I love
what if it's like swinging from branches like a monkey?
Oh yeah, could be. There's also, I think there's some here's the paleo art of it in all yesterday's. The idea that they have like signaling feather displays like at the end.
Well, I mean, really fluffy a big tail makes you look bigger, so that always helps.
As well. But they've got them
peacocks.
Yeah, kind of just like directly held up to help keep track of each other. I don't know. It's a cool idea.
The color scheme on some of these artworks remind me of the Chinese dinosaur, Sornithomimus. No, Sinosynopteryx.
Oh, I see what you mean. Yeah, I think I found the one you mean.
Sornithomimus. What am I on about?
And then of course there's also the idea, which is actually shown in the Walking Dinosaurs episode, that they have these really relatively big eyes for their size, and that would help them see in the months of darkness they'd be experiencing at these high latitudes. But then other work has said that could be because the material is actually from a juvenile, and juveniles have like relatively big eyes for their body size. But then there's actually some work from 2017. I don't know if it's published, but it's like in a poster report somewhere I keep finding online. They synchrotron scanned the skull material, and again they found it would have had good eyesight based on the anatomy of the brain structures and stuff.
So yeah, a bit like those Troodontids earlier.
Yeah, similar sort of idea, but in an ornithopod. I think it probably did just like endure these long periods of darkness. They say it probably didn't migrate because small-bodied animals, terrestrial animals generally generally don't migrate. So it probably spent the dark months.
Well, considering it is smaller, it's not going to need as much to survive, is it? Really?
Yeah. But then the interesting thing is, apparently these dinosaurs weren't even hibernating over the winter. There's no evidence of that based on thin sections taken of the bones. That it actually shows like similar growth patterns to dinosaurs from lower latitudes. So I got this interesting quote from one of these papers where they did this osteohistological study, so taking these thin sections and looking at how the bone is deposited over time and working out like growth rates. It says a previous osteohistologic study of femora from a Victorian is in Australia, Victoria, podotheropod and Hypsilophodontids suggested that these dinosaurs were behaviorally different. Presence of zonal bone was interpreted to mean that the theropod likely hibernated during the severe winters, whereas the absence of zonal bone in the Hypsilophodontid suggested that it remained active and continued to grow throughout the winter. This hypothesis continues to influence interpretations of polar dinosaur behavior and physiology. So yeah, apparently they didn't hibernate, at least as far as we know.
So they probably didn't live very long either then.
Yeah,
No.
I don't know.
So wait, but does that hypothesis still work for the zonal bone one, or is that just kaput?
I'm pretty sure they find that in it. So I'm opening the paper now.
I was wondering how you would interpret hibernation from bones.
So they say even the polar theropods didn't hibernate seasonally. And so apparently none of these dinosaurs were hibernating, at least.
To be fair though, would you be able to spot torpor from the histology? Because a lot of animals we confuse hibernation for torpor, and it's not the same. Whereas it's that sort of like reduced state, but not really hibernation where
I guess maybe stops. Yeah, if they're still finding zones of like reduced growth, then maybe. That's also shown in Walking Dinosaurs where they go into like a group torpor where but that's like a last resort that they can only do that for a few days. So maybe in like really severe conditions they'd have to. They didn't regularly do that, but it's very interesting. I think more work needs to be done on that sort of thing, and hopefully we'll see that.
It could just be a more mammalian thing or some. I don't know.
Yeah. I'm gonna try and find the next one.
I'm not really sure what the prerequisites for like hibernation is. Like what do you need to sort of survive that?
Yeah, I know the term for the equivalent of hibernation in ectothermic, so cold-blooded animals, is brumation.
Yes.
It's actually like a quite different thing that they do. I'm trying to find these papers.
Bro, dinosaurs making their own antifreeze. That's what some amphibians do. I think insects as well.
Well, I was going to say from is it how do you say the name again?
Lianosaura, named after the paleontologist's daughter, apparently.
Lianosaura. We can move into is it? Oh bugger, man! These names are so hard to pronounce. Ichthyosaurs.
Excuse me.
It is it's from Australia as well. It's lower down in geological time, so it's from the Albion. It's from the Albion, but it's also an elasmaria.
Yeah.
So
that's the big
Lianosaura is a elasmaria. So this is Diluvicosauria, which is
I don't know how are you spelling that?
So it's literally DILUVI. CURSOR. But it's also another dinosaur with an incredibly long, unossified tail.
Oh yeah, also Humerella Formation is in.
Yeah, and it's found that it was excavated at Dinosaur Cove.
Yeah.
But
I was just
Pardon?
Could there be synonymy there?
There could be, but this is from the Albion though. I don't know. It was Lianosaura. That's from the early Albion.
It's the same formation.
Huh.
Humerella Formation. There.
So there must be so many differences in the description that. Well, when was Lianosaura found? That was found in 1989. What? Why did they not mention this thing in the?
Yeah, I don't know. I haven't really seen much of this, but it's interesting.
Yeah, no, I thought I'd just bring it up because it was another long-tailed ornithopoda from Australia. So, I thought I'd just bring that up. It's an interesting that you're getting some interestingly long-tailed dinosaurs.
Yeah, what's this? That's only 38 caudals, is it saying?
It does lend more. I mean, if they are separate, it does lend more to that insulation.
Yeah,
feather
if they all have
thing.
quite long tails.
Huh.
I
That's
was,
a nice idea, though.
Yeah, the one. So I think honestly, this might be my favorite Australian dinosaur now. I'm very excited to talk about it. Might be controversial, but Muttaburrasaurus.
Oh,
Oh,
Muttaburrasaurus is so cool.
I love this dinosaur. It's like, I don't know, I always kind of considered it to be, I don't know, just like Australian iguanodon. And when it was first named in 1981, they identified it as an iguanodontid and were basically like, yeah, it's Australian iguanodon. You see all the reconstructions of it, they have like, that's actually quite
They have it
similar.
like exactly the same.
Yeah, with like the thumb spikes and everything. That one doesn't. That's actually good.
Oh my gosh, the
but-
hands look very human-like. It's
So-
quite scary,
oh,
actually.
It's coming up with Jurassic World evolution things.
If you look at the one,
Ah.
the mounted skeleton at Queensland Museum, it looks very human-like, and that is scary.
Yeah.
Oh my
It's-
gosh.
Yeah, so it's named after the town in Queensland. Is it just called Muttaburra?
Langdoney.
Um,
Langdoney.
yeah, there's so quite
Not at all.
quite a few papers were done on this. 1996, they realized it's actually quite different and was not an iguanodontid. It probably broke off the lineage before other non-iguanodontids evolved, and so they think it's something called a rhabdodontomorph.
Yep.
Um,
Raptodontomorpha, yeah.
Isn't that those Zalmoxes and all them lot?
Yeah, that's.
Transylvanosaurus.
I'm pretty sure that's.
Yeah,
they're
Zalmoxes, Moplodon.
rhabdodontids.
Also, is this quite a big Raptodontomorph then?
Yeah, that's the thing.
Have you seen the size of Muttaburrasaurus?
I think it is some like
Yeah,
convergent
Big.
gigantism to an extent. And yeah, it's actually like a very different animal to iguanodon. It's not just Australian iguanodon. It was actually quite gracile in comparison. Likely didn't have the thumb spikes they decided in 1996, and probably were obligate bipeds. They only walked on the hind feet, and the front limbs weren't like for weight bearing. And I think they probably weren't even able to switch like iguanodontids could.
Have you seen the back legs though? They're absolutely robust.
Yeah.
They're massive.
I mean, in comparison to iguanodontids, and I think that might be based on an iguanodontid. I'm not sure. But yeah, obviously the most iconic thing about this dinosaur is this massive, like, structure on its snout, which they call a nasal bulla, and it's actually hollow. So obviously in walking dinosaurs, you have these reconstructions of them like inflating air sacs out of these bony structures. That's obviously hypothetical, but it could be the case that that's what they were doing. The really interesting thing is, though, there's an older specimen of Muttaburrasaurus. I think it's from a different formation. Definitely like quite a different part of Australia. It's like been briefly described, but it could be a new species potentially, because it has a very differently shaped nasal bulla. So that could lend some support to the idea that these were display structures. And there's also some differences between these two specimens in the tooth structure. So they could be like maybe, as we've been talking before, like an example of anagenesis or something, like an evolutionary sequence of these animals changing over time. Or they suggested sexual dimorphism, so males and females having different kind of structures. But yeah, obviously need a lot more specimens. That'd be nice.
Yeah.
And I mean, it was probably a display structure, let's be real. That's when you have these weird structures in extinct
Although
animals.
I remember this was probably like far back in the day. I remember seeing some chatter that it might have been like to warm up air. I mean, if this is a polar.
That's an interesting idea. Yeah, I mean, I haven't read much about like the specifics of the internal structure.
Yeah, you know how you get like some Arctic mammals that have like larger nasal regions to warm up that air. Like I think might be some I don't know what it is.
That'd be a cool idea. Like turbinates, something like in mammals. I think that's what they're called, right? Where there's like the really thin bones that like warm up the air as we breathe in. Yeah, weirdly enough, there's some evidence that actually led the people who named this first to suggest it might have been omnivorous. Because it has a really wide back to the skull, so what they call the post-orbital bar is really broad. and then so they think it anchored helped in dispersing stresses when it bit down. And its teeth are really weird for like ornithopods.
You take that back.
What?
You take that back.
The tooth.
Leave it alone. It's
beautiful. No, but it's cool because they've converged with ceratopsians. So instead of instead of in Iguanodon and Hadrosaurs, the teeth have a single cutting edge and they like shear against each other. Like in ceratopsians, they don't have hadrosaur-like dentitions; they have ceratopsian-like dentitions, which is quite strange. So
that must be a flora change. Something's going on with flora that they have to. Yeah, they're eating similar things.
I think it is probably just they were processing like really tough plant matter, but one of the original ideas was that these shearing teeth and a really strong musculature, stress dispersing bones. They were like, oh, carnivorous then, ate meat or something. But no, it's probably just tough plant matter.
We've all seen those videos of cows eating snakes. Yeah. So let's. there has been in most time. Dinosaur herbivorous dinosaurs existed. They definitely ate some meat.
What's that idea of elephants eating meat as well?
Yeah.
I haven't seen that yet, but I've seen lots of them, like cows do it.
Yeah. Oh, it's scary when you realize they do that. Yeah. I mean, you'd expect some, but they probably weren't specialized.
No, definitely not.
Of course, but yeah.
Not with Australovenator around.
I was about to go into that, so. If you wanted to talk about that,
it's cool. That's all I got to say about it.
It is really cool. So it's probably.
But what is Australovenator, Eddie and Ben?
It's still accepted to be a Megaraptoran, right? Yeah. Okay, that's fine.
Yeah, Megaraptoridae.
So the known bones of it. I've only looked into at least sorry, I'm trying to find like a good. There's a nice reconstruction.
2010 phylogeny by Benson. Carno and Brissetti put it as a sister taxon to Cthulhu-raptor.
What?
Cthulhu-raptor?
Cthulhu-raptor.
Oh,
okay. Yeah. Oh, yeah, I honestly thought you said Cthulhu-raptor as well. Oh,
hey, that's a nice name.
That's a good name.
Well, I think Cthulhu-raptor is also a Megaraptoran.
But now there's the 2014 analysis by. Oh, did we not just see this guy earlier? Porphyry et al. Finds that Megaraptorans to be a Tyrannosauroids.
Yeah, if you take into account Naish's recent phylogeny on his Eotyrannus monograph, and it's a Megaraptoran which falls within Tyrannosauroids.
Yeah, which is really interesting. So the
dentary of this thing is really slim. Wow.
Yeah, no, they're really gracile, these Megaraptorans.
Yeah,
because they've got like fairly large arms.
Apparently, the paleontologists who worked on Australovenator called it the cheetah of its time. Which
no, you don't do it dirty like that.
I mean, it's an analogy, I guess. Kind of gets the idea of it in your head, but it has quite a graceful skull, small teeth apparently, and quite long arms. And isn't there? They found they were really flexible.
Yeah,
and I think that's the main prey capture mechanism was.
Yeah. Well, generally they're
amazing
fingers, and their first two are highly enlarged with huge claws on.
And then so I found the paper where they talk about this, and they're like, oh, it also might have kicked at its prey, just because they found some pathologies on its limbs, like its feet, that I think could have been caused by kicking at something. But like, oh yes, cassowary dinosaur. I mean,
but it is a dinosaur.
Yeah, another dinosaur.
That's interesting.
Yeah,
they said. Oh, sorry. Yeah, go ahead, Eddie.
And I was wondering how much material there is. I wasn't sure.
Not that much.
Yeah, I was gonna say I don't think
it's a complete right leg. You got a femur.
Oh, here we go.
No, looks like you got a fibula. You got a complete arm and a dentary and a few ribs. But I was gonna say that apparently they stated that there's a talus bone from Australia, and they thought it belonged to Allosaurus.
Oh my god! Okay. Yeah, I was gonna talk about this.
And this bone likely represents Australator or a close relative to it. Alternatively, this bone could be an Anabellosaur as well.
Well, okay, yeah. So I read about this because, spoilers, I'm working on the next Walking Dinosaur review, and I obviously came across this. So yes, a singular stragulus, so this ankle bone, now it's believed to be from Australovenator, at least like most recent papers have put it as that. But it was described in 1981 from the early Cretaceous of Victoria, and they literally said it was a late surviving smaller species of Allosaurus, like the genus North American genus Allosaurus, and they think it survived as like a dwarf form in the polar forests of Australia.
But not for that long.
Yeah, so obviously that explains why in Walking with Dinosaurs they went with this idea of the polar allosaurs, they just called it. But yeah, that's quite an extraordinary claim and was not accepted by many people, but Walking Dinosaurs went with it. And then this single Astragalus has gone through a few classifications: ornithomimid, a belisauroid, and now it's back to an I put Allosauride, but no, not Oh yeah, so someone said it was an Allosauroid, but not actually Allosaurus. And now it's thought to be Australovenator. So
yeah, see that
interesting.
Australovenator is not actually like that small either. I think it's currently estimated to be about 6 or 7 meters, which isn't anything to sniff at. Yeah, it would have been fairly large, especially if if some of these unpublished claims are right, where there are actual tyrannosaurs and spinosaurs there as well.
Yeah,
because obviously when you look at the rest of Australia's fauna, you have got some decently sized titanosaurs and other fairly decently sized herbivores. So it's like, where are the predators?
It'd be so cool to have more fossils.
It's reverse chem, that's what it is.
I mean, as it is with most megaraptorans, you need more material. It just doesn't exist for them for some reason.
Yeah, one of the things I kind of praised the Walking Dinosaurs episode for was kind of tackling this kind of environment, like especially back in the 90s when they were making it. It was such like an unusual and relatively poorly known kind of place to reconstruct, and even today, like we know more, but not that much more. And it'd be cool to understand this place and what these like in this extreme environment, what these dinosaurs were doing.
Yeah, especially in Australia, considering how different their fauna is. Like,
yeah,
well, you have got these conditions in the rest of the world, like in the northern hemisphere and all that, but their fauna is just completely different. It's because it's been isolated for so long.
Yeah. So shall we continue our journey south and head on to something I know, Hamza, you've been very excited to talk about.
Yes. I think this dinosaur has to be one of my favorite dinosaurs.
It is an incredible...
I swear they informally called it Elvis.
They did.
Yes. They did. But, sorry, I need to fix my camera. Something's going wrong with it. But,
Here we go.
Is that better?
Oh, that skull. Oh my god, I can't believe they found this. They were so lucky.
It's brilliant. So Ben will be showing you an image of Cryolophosaurus elotii?
Elotii?
However you pronounce it, but Cryolophosaurus.
Elotii. Yeah.
Elotii. And it's an amazing animal. It's found in Antarctica. Like, come on. So it's a Jurassic theropod. Yeah. One thing it's probably the largest theropod of Antarctica so far. But the weird thing is that the cranial morphology of Cryolophosaurus shows some derived features, whereas if you look at the skeleton as a whole, it's very basal.
Yeah,
so something's gone with there. It's got some very interesting features that kind of look similar to Dilophosaurus, where you got that notch in the skull. But we have to also mention Cryolophosaurus' most famous ornamentation on its head. They think, of course, it's probably going to be a sexual display, social structure as well. Yeah. So,
when you've got when you've got structures like this, it's usually display of some sort.
So they're primarily for intra-species recognition, based on evidence related to studies on bone texture. I had a whole list, by the way. I had a whole my notes. I've lost the book. So I have to remember what I said.
I found it interesting how apparently the way they found it. So it was named in 1994, and I believe it was actually the first dinosaur named from Antarctica, right? It wasn't the first one found there. It was the first one to get an official name. Pretty sure.
Yeah.
Yeah, because you had Antarctic Pelta, I think.
Yeah, that was the
around
first.
the same time.
That was the first one found, but it wasn't named until quite a bit later. But so they found it on Mount Kirkpatrick, which is actually in the Trans-Antarctic Mountains. So it's on the Antarctic main continent itself, not the bit going out where a lot of the other ones are from. And yeah, the front bit of the skull had been glacially eroded out of the cliff face, so they're only left with back parts. You can see here in the holotype.
The back part is still amazing.
Yeah, the fact that the back part preserved this insane crest structure, they're so lucky. But they found some bits of teeth and fragments of the front bit.
Oh, yes, probably.
Well.
Yeah, go ahead, Ben.
Yeah, no, I mean the crest is just so interesting.
Wait, so there could be more crest on the front of a skull?
Maybe. I don't know if it would continue down there.
Continue what Ben said. In the stomach region of Dilophosaurus, they found a
wasn't it
mammalian tooth.
Oh, mammal. Sorry,
So they found a mammalian tooth in the stomach region. But what's really cool was the original idea of how this animal might have actually died.
Yeah.
So they found the cervicals in the cervical region, the cervical ribs, and they actually thought they belonged to a prosauropod. And they thought Dilophosaurus had choked to death.
I love that idea.
But that idea was debunked later on, and
I think it was just from Dilophosaurus itself.
Yeah, so the cervical ribs may have actually just come from Dilophosaurus as well. But they also found so some of the bones in Dilophosaurus actually showed scavenging. So they're broken teeth from younger versions of Dilophosaurus. And apparently there was a really bad foot injury. It's quite the ankle bone to the astragalus. They found a crack going up the fibula.
All right.
Right above the ankle. And I'm sorry, that would have just messed up your way of hunting.
Yeah, that's not a good place to have it.
Isn't that what happened to Big Al? Like Big Al broke its toe or something.
Yeah. Well, that could also be a sign of not just scavenging, but also whenever they talk about injuries in Tyrannosaurs, they always say, "Oh, that's an evidence for social behavior."
Yes, let me bite your foot.
Well, there's no way this animal could have survived by itself.
Oh, so yeah, it was helped by the members of a group.
Like the ceratopsian idea they did with the tumor growth, and they're like, these other ceratopsians helped it to adulthood or something.
Yeah, some stuff like that.
I've not heard that.
I've heard things like that. None of that specific.
I'll send to you later, Eddie.
Okay.
Yeah, so obviously the classification of Dilophosaurus has been kind of all over the place. I got written down that it was considered a ceratosaur or an earlier belissaur first, and then was placed as an allosauride, then as just a basal tetaneuron. I never know how to say that word. This major group of theropods.
I find that word very funny. I don't know why.
Tetaneuron or tetaneuron, I don't know. But
tetanurans.
Yeah, it's also been placed as a close relative of Dromaeosaurus from South Africa and Dilophosaurus itself. I'm trying to find where are these.
There's a new recent study, 2020, that just puts it as a Neotheropoda.
But still kind of is the big this is the Dilophosaurus monograph.
Oh, is this the Dilophosaurus paper?
Pretty sure this is the huge study on Dilophosaurus. And yeah, basal neotheropod. There it is. But it still is close-ish to Dilophosaurus. So but more basal.
Zupasaurus.
Yeah, I see that.
You have to pay the source.
But it's so interesting.
Did they not find it in a environment where it's heavily volcanic?
Yes.
Yeah, there's evidence of that, which is quite cool.
There's a really nice photo of it, actually. I'm looking at it now, where there's these two Dilophosaurus just watching a massive explosion just go off. Yeah, it's called the Hansen Formation.
It does make you think, though, because what else have we lost from Antarctica? Like, what else could be under there?
Yeah. Oh, okay. So, leaning into that, I was gonna. Okay, so basically we're moving. So yeah, Hansen Formation. Now we brought that up. That's the early Jurassic formation that Dilophosaurus is from, and it's from the actual main continent itself. Yeah, so the other main place they find dinosaurs in Antarctica is on James Ross Island, and there's some. I think there's a couple of formations here, but they're Campanian in age, so it's all late Cretaceous. So like a very different, a lot later than what you see in the where Krylophosaurus comes from. Now, interestingly, Hamza, you might be interested by this.
Oh
no, I've got too many tabs open again. There are some reports of very fragmentary sauropod bones and theropod bones from this other place. Let me get.
Oh.
Sorry. Let me get it up. And it's just, yeah, it's interesting that they're kind of.
Oh, you got me on the ropes then. I was excited.
Well, yeah, it's just like there's these really fragmentary remains of some sauropod vertebrae, and it's like, oh, okay, yeah, there's a lot more to be discovered here. It's just very
barren.
Yeah, very harsh conditions, obviously, to kind of fossil hunt in.
You're not going to find your nearest Tesco's or Sainsbury's around the corner.
Sadly not.
Just go out, grab the milk, come back.
Yeah. This is the first record of a sauropod from Antarctica, and it's from the same locality as a couple of other named species that we'll get to in a second. It's probably a titanosaur, and yeah, it's just pretty cool that they even spread to Antarctica. The origins and dispersal of these titanosaur groups aren't particularly well known, so this kind of adds to that.
Well, yeah, you've already got Diamantinosaurus from Australia, so with all these other reports of titanosaurs, definitely makes sense that they spread this far south.
And there's also also some reports of just a fragmentary theropod bone from James Ross Island. Not enough to really name it as anything. But there's still more there to be discovered, which is my main point. Moving on to the dinosaurs that have been named from James Ross Island, we have something called Trinisaura. Yeah, you probably got the Trinisaura. You've got the notes there, right?
Trinisaura.
Yeah, so it's just this little ornithopod. Another Elasmarian.
Elasmaria.
Yeah, named in 2013 from James Ross Island. A partial skeleton without a skull. Hopefully it shows the material here. It doesn't, never mind. And it's just, yeah. Well, it was first thought to be a basal ornithopod, but it's actually, an Elasmarian.
It shows we need more research in Antarctica.
We
just need more teams down there.
I mean, yeah, you might struggle a bit with that.
So from the paper talking about this dinosaur, I've actually got a quote, because I just like this quote. It says, "Such a limited record could be biased by the logistics involved in Antarctic explorations, which determines significant investments and reduce time frame, which determines significant investments and reduced time frames to carry out fieldwork." I think that was a mistyping there.
So what you're saying is no.
Well, what I'm saying is we need to go there and find these fossils, because there's clearly a lot more there. It's just the difficulty of working in Antarctica. So, BoneHeads.
Yeah, what? Pack a flamethrower.
BoneHeads 2022. Wait. What?
2023.
Yeah.
By the time this comes out.
That'll be the big trip.
But
imagine. I would not be able to do that.
Do what trip? What did you just say? What trip you wouldn't be able to do?
Antarctica.
Oh.
Now we're going to Antarctica. Okay, but moving on to Antarctic Pelter.
Oh, you beat me to it.
Oh, I'm sorry. What were you gonna say?
I was gonna say, moving on from one James Ross Island to another. We're going to Antarctica Pelter.
So you like this dinosaur? I've heard.
Yeah, it's a weird animal. We don't have many remains, but from the recent Ankylosaur, is it Ankylosaur? No, Para-Ankylosaur from South America, we have Stegosaurus. And we actually think Stegosaurus's tail may be similar to may have similarities with Antarctica pelta.
Yeah,
just because of phylogeny. So they placed them as sister taxons.
Oh, it's adorable. Stegosaurus is tiny.
Antarctica pelta is not.
No. If you've been following recent paleontology news, or you're like a fan of some of the science, perhaps, you may remember last year this Stegosaurus being described that has.
Was Stegosaurus last year?
Yeah, 2021.
Yeah, last year. Oh my gosh!
Only just.
I thought it was this year.
But it's got this. Yeah. How do you pronounce it?
Makhitol.
Yeah, this
Oh, where's that? I want to try and pronounce it.
We'll get butchered for it, but
yeah, probably.
It's fine.
It's an Aztec
club.
Yeah. And they've compared the shape of its tail, weaponry, ornamentation, whatever, to hit these Aztec clubs, which is pretty cool. And so yeah, Antarctic pelta itself. Let me go through my notes. This was named in 2006. Collected in the same place as Trinisaura we just talked about, and also in the same place as the indeterminate sauropod.
The remains aren't brilliant.
No, I think this was the first dinosaur material to come out of Antarctica, but it wasn't named until 2006, so it was beaten by a few others.
Can you imagine being the first person to go fossil hunting in Antarctica? You must have been cool insane.
Yeah, probably.
Imagine the project proposal. Oh, I think there's something there. I can do it.
Yeah,
just give me a few minutes. I can do it. It was
But
found in 1986.
yeah, so it's the first reported ones, right? Wait,
Yeah.
no.
Yeah, because Carlothus was 1994.
Okay, yeah, that sounds about right. And yeah, so they were confused when they found this because they put it as an ankylosaur, but they realized it had features similar both to Nodosaurid and Ankylosaurids. So Ankylosaurids being the clubbed Ankylosaurs and Nodosaurid being the clubless ones. But then it makes more sense now that we've got Stegosaurus, because when they named that last year, they also classified a nucleate called Parankylosauria, which is basal to the main split, right? Yeah.
Mm-hmm.
So you can kind of see here, it shows it quite nicely. You got Parankylosauria, then Euankylosaurs, and that's where the Nodosaurids and Ankylosaurids would be. And so yeah, they found Stegosaurus to be the sister taxon, very closely related to Antarctic pelta, which is pretty cool. And then they also added in Kunbarrasaurus, which we can talk about now, I guess. It's another Australian one. Has really good material for it.
Well, isn't Antarctic pelta a subadult as well?
It might be. I don't
think
recall.
it is.
But it's yeah, they found
I'll have a read around if you want to.
They said it had pretty this combination of characters, and now that kind of makes sense that it's from this basal lineage. And they now think it's probably likely that all of them had this this kind of tail anatomy, this tail weapon.
Yeah, very.
I was just having a conversation with Ben earlier about this. You would think a tail like this wouldn't be so. As we talked previously about the ankylosaurs developing their clubs to fight one another, this tail isn't that thick, isn't that robust. It's quite flattened. It's quite spiky. So you wouldn't imagine that actually hitting another armor shield because it will break. But the thing is, what I can imagine it doing is knocking the legs out. It's quite a small animal, Stegosaurus. And Antarctic pelta is quite small compared to some of the ankylosaurs. So I can imagine this thing going for the legs, cutting the legs, hitting the legs.
I mean,
I don't know.
Could certainly be used as a weapon.
FDA
but I feel
at the end of the day.
Yeah, they need to do that.
Give it a good old stress test.
Yeah, but it could just be display structure again. And I was saying how it's interesting.
That's something you'd have to test.
It's interesting that the Parankylosauros. Sorry, yeah.
If you can confirm that the Parankylosaur tail is a display structure, then it shows Ankylosaur clubs didn't evolve for defense against predation.
Yeah, and it's interesting. Like Parankylosaurs have this kind of tail ornamentation, and then Ankylosaurids have their tail clubs, obviously, and then Nodosaurids don't. So is this are they homologous? Is this a kind of convergence, or
Oh, that's
what's
true.
happening
Could
there?
it be?
It's interesting to
Didn't
think
think about that.
Yeah. Yeah, I mean, oh yeah, sorry, have got stuff about the juvenile thing. It's at least a sub-adult. It was originally considered juvenile. Antarctic pelter, and it's not too bad material. Quite a few bits of the skeleton.
It looked like there's just bits and bobs, really.
Yeah.
Bits of the feet and stuff.
But then Kunbarrasaurus.
Nothing too amazing, not like some of the other ones we've seen.
Yeah. Do they what do they seriously not have anything on the holotype of this?
Really?
Not on the Wikipedia page. Hang on, let me find the paper.
We definitely did not just say Wikipedia.
It collects everything together, and they usually got good figures, but they don't have like
the Wikipedia page has an amazing skull figure. What are you on about?
But I swear they have like the whole skeleton.
I don't think so.
I think they did. I thought it was scraps.
Yeah.
Are you getting mixed up with Minmi?
No, because this is what Minmi used to be. Hang on, I swear. Hang on.
Also, it might be that if Minmi was once Antarctic pelter, it could be that the good skeleton you're referring to.
Oh no, yeah. So people are probably familiar with Minmi. Wait, okay. Did they only describe? I'm pretty sure. I swear I'm not going insane. Kunbarrasaurus has like a really good. It does. Okay, there we go. Yeah, Kunbarrasaurus has this incredible complete skeleton, and they weren't showing it in like anywhere. I think they only described the skull in that paper. Basically, Minmi for a while was the only known ankylosaur taxon from Australia.
Oh wait, we're not talking about Antarctic pelter. Okay.
Well,
no, we're talking about Kunbarrasaurus.
It's related to it. It's a close relative. And so yeah, they found this really complete specimen in 1989 in Queensland, and then it was like initially described while it's still being prepared in 1996 by someone who's assigned it to Minmi because they're like only one ankylosaur is known from Australia so far, and that's Minmi. So they're like, this must also be Minmi. But when they properly examined it in 2015, like, this is not Minmi, this is something else. So they named it Kunbarrasaurus. And it turns out it's also a close relative of Stegosaurus and Antarctic pelter. It's another
parent the same tail globe.
Probably. They say it probably did, because we don't actually have those bones, sadly. Yeah, I mean...
Do you know what we say to that? Go find one yourself.
Yeah.
But that's very interesting. You've got all these very closely related parrot and ankylosaurs all from around the same area.
So obviously they, probably all went south and kind of radiated out.
We're going south for the winter, boys.
Yeah. And luckily for this specimen, at least, like, the skull is very well preserved, so they can look at the internal anatomy of it. And I don't know if people are familiar with how complex ankylosaur nasal passages are. They're like quite well known for being really weirdly like looping and really complex.
Balloons.
And so they looked at what this was like in Kunbarrasaurus, and they said it had pretty complex internal airways, but not as complex as in more derived ankylosaurs, which is interesting. So it's showing this like, they say it's a mosaic combination of basal and derived ankylosaur features, which makes sense for it being a parankylosaur. So yeah, I really like this specimen. It is quite incredible.
Indeed.
Australia has some very cool dinosaurs.
Yeah, no, I know.
Derived skulls and basal bodies.
Yeah.
There's still lots more work to be done in Australia.
Absolutely.
And it just shows like when the work is done, how amazing it is.
Yeah. No, it's...
Oh yeah, there's a whole world right out there, outback. Wasn't there that giant sauropod footprint with a guy like lying in the middle of it, and they thought it was the world's largest sauropod footprint? That was from Australia.
Yeah, there's something in Australia. I need to cover that in my sauropod video at some point.
I got some great trackways.
But yeah, Eddie, to close this out, kind of, do you want to talk about, or actually going back north again to the Arctic? Do you want to talk about this paper finally?
Oh yeah, like
yeah.
Yeah, I could talk about it quickly.
Okay.
So this was when we first sort of discussed the idea of talking about polar dinosaurs. I remembered this paper from earlier this year. I think it was around June or July, something like that. And it was actually talking about these Triassic specimens of sort of prosauropoda, and they had in these formations from a Triassic, but actually had evidence for freezing winter temperature. They found like ice raft debris and other stuff like that at these high latitudes, which is really interesting. I think it's the Jungar Basin. It also extends into the early Jurassic as well, and it had an altitude of 71 degrees at the time, so that is like really high. Like I think some of the stuff we were looking at earlier was like 60 degrees, so it's very high. Oh no, they didn't find bones there. It was dinosaur footprints they found there, of course. But generally, so they made a map of where a lot of these early dinosaurs have been found, and generally they are from mid to high latitudes. And so, sorry. So sort of rolling with that, they sort of found that actually, but yeah, there's not many herbivorous dinosaurs at low latitudes, but also you don't really find many other like non-dinosaur archosaurs at higher latitudes, and mostly around the central latitudes.
Yeah.
They also do a phylogenetic analysis and find protofeathers for insulation basal for Ava metatarsalia, so that's pterosaurs, dinosaurs, all them lot. So I mean, yeah, a lot of this study does rely on a lot of evidence lining up and not exactly their own stuff, but they sort of all package it together to come towards this theory. But yeah, obviously it does rely on that phylogenetic study.
Yeah.
But if feathers are protofeathers are basal, then they are for insulation, and that would help them at these higher latitudes where it is freezing. And yeah, so they proposed that they couldn't actually compete at lower latitudes due to unstable flora resources and a higher metabolism. But whereas at higher latitudes, like there's different flora, and like we've got tree rings from there which are consistent with a cooler climate, and they were more stable, so they could eat them all year round. Yes. So they also say that Pseudotsuchians had endothermy, so that's like warm-blooded, but they didn't have the insulation. So they go on to then talk about the Triassic extinction, which we've learned about recently, and you remember camp volcanism, right? Like that really large scale volcanism. Basically, they're saying
as Pangea was splitting,
this would have released a lot of sulfur aerosols, creating volcanic winters lasting over 10 years over like the transition of about 1 million years to the Jurassic. And they say there's evidence for like sustained drops of 10 degrees even in the tropics. So that would have caused like major that would have major consequences for those tropical fauna, which is sort of what they say helped give dinosaurs the rise they needed, because it then suddenly changed these lower latitudes into an environment that they were more adapted for, and these other archosaurs were not, because they didn't have the insulation to survive. And they also say there's little evidence for dinosaur extinctions at the boundary, but other large archosaurs were hit. And they did another interesting thing I thought they did is they were actually able to sort of separate the groups of archosaurs that go extinct throughout the boundary, and they were actually able to separate them into insulated and non-insulated, compared to like there wasn't any size selectivity, so it wasn't like the big ones went out or the little ones did. It was just, did they have like a form of integument or something to keep them warm during those volcanic winters. Yeah, and I just thought that was really cool because, well, I mean, we've talked a lot about these polar dinosaurs, and this is sort of where it all stems from. This is sort of how they survived those conditions that allowed them to actually rise to the dominance they did for so long.
Yeah, it's nice to kind of see all this put together.
With birds, you think how many birds live at higher latitudes today? I mean, you look around, there's so many of them, and they could sort of owe their thanks to these ancestors back in Triassic surviving the Triassic extinction because they had integument.
Yeah, no, it's
Yeah,
a
I thought
good
that's really cool to bring up.
combination of different lines of evidence, like the ice rafting
Yeah,
debris and everything.
it definitely relies a lot on lots of things coming together, but they
Yeah,
managed to bundle it into a very good theory.
yeah, it was interesting. I remember, reporting on that when it first came out, and it makes sense.
Yeah.
But yeah, no, it's really cool. And there's just so many fantastic polar dinosaurs and ichthyosaurs and plesiosaurs.
Oh yeah, there's loads more you can look into. We haven't
in
mentioned.
the north and the south. Yeah, I've had to
Still
skip
more
over
to be
stuff.
discovered.
I think I will make like not a podcast episode, like a regular video kind of about this stuff, just because it's so interesting and everyone loves polar dinosaurs. And yeah, hopefully this has been enjoyable to watch. I know it's been different to our usual format. It's just because everyone they've gone home.
Hold back the tears.
Yeah, but we'll be resuming again in when do you think?
A week or two.
Yeah.
Yeah,
probably.
Eddie, you come back like end of first week, don't
Next
you?
week. Yeah.
Yeah, I come back literally the beginning of that week.
Yeah, so
okay.
we'll be back to normal very soon, and we've got an exciting trip planned soon.
Do we?
Yeah. No, I've decided I don't want to go anymore.
Okay. You know,
yeah, I'm gonna give my place to some random subscriber. No, I'm joking.
Okay.
No.
Yeah, we're gonna be
no.
making some cool videos.
Can you imagine?
Yeah. A lot more some more fossil hunting out in the field episodes.
Don't spoil it.
Yeah, we're not saying where, but it's gonna be really cool.
Yeah, en masse there'll be the fans.
Yeah.
The Eddie's watching.
What?
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 Yeah, no, I'm excited for that. I hope you are also excited.
Yeah, no, I'm very excited for that. It's been.
I'm excited. I'm not excited for the journey.
I'll be fine. I'll be fine.
I'm not excited for the journey.
We're going to Alaska. No.
We're going to the Antarctica.
Oh, I want to.
This is why we did the episode early.
Yeah, obviously. We can make it happen. I reckon we could get to Antarctica.
Yeah, it's like a boat ride from UK.
Yeah, that'd be fine. My parents used to work for the British Antarctic Survey, so...
Yeah, we should ask your mum about...
yeah, she could get us there.
Plug in her YouTube channel, but we can
yeah, definitely. We'll probably have her on at some point, talking about...
Yeah, talk about her travels during Antarctica. That would be interesting.
Antarctic expeditions and everything. Yeah, I will be seeing you both in person shortly,
Fairly
hopefully.
Yeah.
I hope you've all enjoyed watching this, and I hope you have a good holiday and good New Year's. I'm gonna aim to get this out on New Year's Day. So.
What do you mean? What? 2 days.
I think that's this Sunday, right? It is on Sunday.
Yeah.
Yeah.
This Saturday.
Oh, okay.
New Year's Day is Sunday.
Yeah. Saturday.
No, that's New Year's Eve.
Oh. I mean, yeah.
We can bleep that. It's fine. We'll put dolphin sounds or something. Anyway, yeah.
Eddie, can you do a dolphin noise for us?
No.
Thank you so much for watching. It's probably a good place to end it, I guess. And Happy New Year. Here's to another year of BoneHeads. Full year of BoneHeads.
Hopefully, yeah.
Yeah.
Bye.
He's just gone. He's out.